In the last session, we have seen about the reactance relay. So now in this today's session, we will be seeing about the numerical admittance relay. Here with respect to your previous circuitry, we are just going to make a small modification. With respect to your reactance relay, we have added a zero crossing detector. Now here we are going to add a phase shifter. It is because you are going to measure the instantaneous value of the current. So here you are going to measure the instantaneous value of the current that you are going to measure with the phase shifted value of your voltage. So you are just putting a phase shifter here, and whenever this phase shifted voltage, that is a zero crossing voltage, is going to be compared with your instantaneous value of the current, you are going to check the condition for your Moore relay. So now here this I by V will give you I by V cos phi gives a value that is a constant. So I by V is nothing but your admittance. So Y cos phi is less than K2, or else I can write it as 1 by cos phi is less than 1 by K2, or in other words M is less than K. So here you are going to measure the instantaneous value of the current. So whenever you are going to have the phase shifted value of the voltage. So you are going to measure the instantaneous value of the current, and with this value is going to fed through your microprocessor, and at that time when you are going to measure your voltage, so this microprocessor will give a signal to your multiplexer to start which channel to be selected. Then the process of sample to hold on circuit will start with, and this sends the data to your ADC, where the ADC, the analog to digital converter, it does the start of conversion after receiving the signal from the microprocessor port C lower. Once all the data have been digitized, then it is going to be given to your port C upper by giving the signal of end of conversion. And the entire circuitry, mark sample and hold circuit and your ADC, it is together called as your data acquisition system, and this system is going to be connected to the programmable peripheral interface to interface your microprocessor with it. So once it is going to measure the instantaneous value of the current with the phase shifted value of the voltage, it is going to give the admittance value. So when this admittance value is going to be less than the required value, then in this case it will issue a signal to the circuit breaker for it to trip. Here also we will have 3-zone protection. Of course, the first zone will be the instantaneous protection, so the relay will act immediately. Whereas in the second case, it will zone 2 protection, it will act after a predetermined delay, and the third point will act after the larger delay. So here you are just going to check whether the value of your admittance is going to be less than the value of the K for the relay to operate. So with this I wind up the today's session. In the next session we will be seeing about the flow chart of your admittance relay. Thank you.